So let's start with an example that's just conceptual, no numbers or measurements, to see if we can do this. And let's say we're trying to find omega of BC. So B and C are on the same solid member on a rigid body, and so we can do this instantaneous center. So first of all, you look at AB, and you see that B is spinning around A, and so it has a velocity like this because B is spinning around A, it has to be perpendicular. You see that C, because it's in a slot, has that of a velocity that's horizontal. So let's try this technique. If you draw perpendicular to both of these velocities, the intersection will be the instantaneous center. Well, perpendicular to this velocity, which happens to be perpendicular to arm, will be directly along the arm. So there, I've drawn that. And obviously, perpendicular to C, horizontal, will be vertical. There's perpendicular. And there we go. That's the instantaneous center. And to locate it, we would have to have some dimensions and angles and that sort of thing. So let's do an example where we actually have the dimensions. Okay, so here's an example. It's very similar to that. A piston, or instead of a piston, a block going horizontal. So let's find the instantaneous center of BD. So the velocity of B is perpendicular to AB, which happens to be coincidentally directly along BD. But the key thing was I drew that perpendicular to that. And obviously the velocity of D is horizontal along the ground. And so we're going to draw perpendicular to both these velocities. There we go. There we go. And that's the instantaneous center. It happens to be, everything's 45 degrees. So this is 0.4 meters, that's 0.4 meters. And that distance by Pythagoras theorem is 0.4 squared plus 0.4 squared square root, which is 0.4 times square root of 2. So we found the instantaneous center. We have the dimensions by using geometry. And now, just remember that the velocity, if you're measuring it from the instantaneous center, just spinning about there, is just r cross omega, which is just r perpendicular times omega. And we see that the velocity of D is 3 meters per second. And it equals its distance. Let me re-sketch that here. There's the IC. There's D. Let's keep the IC the letter O. And that's at 3. And the distance from the instantaneous center to point D is 0.4 square root of 2. We did that using geometry. And so we have 3 equals omega of BD times the distance from the instantaneous center, 0.4 square root of 2. And so we can solve for omega BD. Let me get a calculator and figure that out. So we take 3 divided by 0.4 square root of 2. And I get 5.30 radians per second. Okay, what if they wanted to know what's the velocity of B? The velocity of B, okay, equals r perpendicular from the instantaneous center times omega, which we just figured out, and perpendicular. So that velocity perpendicular to that arm from O to B, the instantaneous center to B, that had a distance of 0.4. We did the geometry for all of that. And we had omega was 5.30 radians per second. I'm going to double check that real quick. 3 divided by 0.4 square root of 2. Let's see. Yep, 5.3. Okay, so velocity of B is just 0.4 omega. And that comes out to 2.12 meters per second. Okay, so that's a classic example of using the instantaneous center.